So I think that today's lecture will end earlier, then followed by the exercise lab as well as the explain about your second project. Okay, so please keep staying here. So I hopefully finish the chapter 11, 12, as early as possible. Then you have a time for exercise lab and project explanation. Okay, so last class we talked about what is a file. So file is a data structure to keep the information. So basically it's a byte stream. So we have the number of the byte stream. So that is the reason to think about your Java program or other program languages. So you instantiate the file, to open the file, to handle the file, you instantiate the file stream in case of Java, okay? Because it considers just the streaming data. So the main problem of managing such a file is nowadays we have the number of files, really the huge number of files. I'm not sure right now on my laptop, but several years ago when I checked the virus, so it's almost 300, 400, 1,000 files in my laptop. Most of them I never seen. So it's part of operating system, and sometimes it's the user file, but which you don't use. So sometimes it takes a time to search the file to specify. So we are going to use another data structure. So to manage the number of files, that is a directory. So on the Windows system, it's called the folder. Okay, so if you think about the folder, it's the same the idea of the directory. So using the directory, so last time we have seen this kind of the slide. So instead of accessing all the file header information directly to search or to handle to manage the file, instead we are going to keep the header information separately on another data structure, which is called the directory structure. Okay. So later in chapter 12 we will see such the header information managed by the directory is called the file control block. So FCB. As we have used the process control block, PCB, on the process test by the operating system, the file system uses FCB, file control block. So these are the number of file control blocks. The file system, operating system access the directory structure when you search. So for example, what is the command of the search to find the specific file on the Linux? Anyone? So I want to search the file, specific file on the Linux system or the terminal, command line interface. What is a command? Find. Find is command. It's one of the really used a lot. So you should, so for example, the familiar with this, so more information you can find from the manual page. But for example, this is one of the find commands I will introduce later regarding when we talk about the permission. So find under the root directory, type is the directory and permission is like that, and the exec, and why the exec is after we list up the file, then check that this one will be returned, something like that. So it's really powerful, the command. So you should know using this command. So that is a find. So when we learn such a find command on the Linux, it searches the information from this directory structure, not accessing all the file, each of the file header information. Okay, so such a we have seen such a type of okay. So such a directory structure supports such an operation. So mainly the search, and also you can create a file on the directory, which means create the FCB information, header information only. Also, we can delete the file. So when we delete the file, remove the file, what happens? Does the file system or operating system delete each and every byte of the data on the storage? No. Instead, it deletes the header information. Okay. So that is the using of the directory when we manage the file. Then we can speed up. We don't have to delete the real file, the byte and byte stream. Instead, we remove handle such as the directory structure. Also, we can rename the file and traverse the file system. So these are the benefits of using the directory. Nowadays, some of the operating system use the different name of that. So like the Windows use such a folder. It's the same. Okay. Actually, slightly different inside, but the idea are the same. We will see later. Okay, so using the directory, the first objective of using directory is fast to search the file. So when we access the data, so main reason, always keep in mind, the most important part of the computer is the efficiency. Okay, so that is the reason in your CS11 and 102 data structure class, so you learned about the bigger notation, the complexity. Because the reason why we are using computer is to speed up for what? Actually search the data information. Then when we search, sometimes we need to process, add calculation and so on. So the efficiency, performance is the most important criteria when we design, use, manage, and whatever is efficiency. So directory is one of the data structure to make the system efficient, the file system efficient. Also naming. Actually, the file system use identifier, file descriptor, FD. So to identify such a file. But that's for the system. For human being user, familiar with the name. So we can create the same name. We can share the same name with the multiple file, but it's confusing for us. The system is okay because the system uses identifier number. But for us, so it will be confused. If I create the student file again and again in the same directory, we don't know which one is which. So to address that problem, so we can use the directory by grouping. Okay, so we can use such the directory structure to group for the naming problem. That is the grouping by combining that is one of the way to organize the number of files. Most of you guys create your own folder for the class, the database, or the operating system, and under the operating system you create a different folder. That is the benefit of using such a directory structure. This is the first single level directory structure you can imagine. So we can create the directory structure. Under the directory we can have a number of files. Okay, so we can keep even though we have the student file, we can create a different directory for each student. Student A, student B, student C, and so on. So we can solve the naming problem, and also we can do the grouping like that. So this is a two-level directory. So because the single-level directory still, for example, if we group by the characteristic of the data, like the data or test. But under the test, we can keep all the student test information, so we cannot classify by the user. So we can have the two-level directory like this one. So there's no problem. When we have from the two-level directory, so we need to specify the directory information to identify the specific file. So user 1, then cat. And finally the file name, that is called the path. So we need to specify the path to locate the specific file information. That is the path. That is the reason we are using the full path of that. So one of the problems of the two-level directory is the searching. So if we search the data, we need to access the user 1, then this one. If not, we need to the backward and the back tracking every time. So probably in the data structure class you learned about the tree and several operations you learned in the tree, the data structure. One of them is the how to search, how to visit. So it's a backtracking. So backtracking is a brute force way. You can visit each and every, which is not efficient. So to address that, we have the generalized the tree structure. That is a generalized the multi-level structure. This is a tree structure. So from the root we have the subtree, and then it point another directory. Finally we can have the file. So to access the specific file, so we can start from the root and the spell, mail, the copy, or and then a.txt file, something like that. This is the tree structure directory you can imagine. So it's we can use the path to access the data. And there are several things you already know. So it starts from the root directory because it's based on the tree. Okay. Then we can specify the path of the file. Also, there are special the notation of the file. The structure. One is the single dot. Single dot is it's a current directory, the current location, and double dot means it's a parent directory. So it supports, if you specify the root, the user, the bin, and the a.txt file, this is a full path. But if you are using this single and the double dot, single and the a.txt file means it's a current directory and the a.txt file. Then the double dot and the bin a.txt file means so parent going to the parent, then find the subdirectory of parent. It's like the sibling directory, and find this one. So in the most of file system, support. So another mostly used command is a pwd. So as you know, pwd shows where you are. So like this one, so I'm currently here. So when you the list of all the file ls-8l, you can see always the single dot and double dot. Single dot means it's a current directory information. This is the parent directory information. Okay. So then if you access, oh by the way, so sometimes you can list, if you list all the file, you can see the dot, then followed by the file name. That is a hidden file. So if you just type the ls, you may not see, you cannot see such a file. That doesn't mean it doesn't exist. It actually exists, but it's not frequently used. So mostly such a dot something file is a configuration file. So as if you see the dot trace is a trace folder. A trace folder, yeah, trace folder. Dot basic history shows your command history. So the dot basic session is a session information, and so on. So for example, the popular example is the VIM or the VI. That is a temporary file for the VI editor. So you can if you want to list up all the hidden file, you can use the A option ls. But that is different from the single dot. Single dot is the current directory. So you can use the ls-al dot. The parent directory all the files. So you can see these are the sibling, the subdirectory of my current JELE. For example, if you wanna list all the file of yes. So you can use the single dot, double dot. This is a convenient way to access the data and the files. We'll go back to this. So I think that you already know such a basic operation of the directory. So you can delete a file or create a file, and also create the directory, subdirectory, and remove the subdirectory. So you cannot most of the case delete the files the directory if there exists a file, so you need to remove. Otherwise, if you wanna remove all the file under the certain directory, you can use the rm command minus r. The R is recursive, so but you should be very careful to use this command. But this is one of the frequently used command. Otherwise, you need to delete all the file and delete the directory. So rmdir or rm. So and you need to do everything, every subdirectory. Otherwise, if you don't want to do that, you can use the rm minus r option. So I usually is recursive. Okay, then the problem of the directory is if you want to access the file from the current directory is under bin, under p, under list. This is my current directory. So we have the file. But if you want to access the file to here, you need to list up all this, the full path, and visit this one. So is there any other way to use such a file? So that is the graph directory structure, especially it's a cyclic graph. What is the difference between the graph and tree?
Tree is top down, or graphs can have edges and anywhere.
Which one is general? Graph is general, which means the tree is a parent and child relationship always. So there is a top, there is a bottom, there is a root, there is a terminal or a leaf. So that is the critical. Because of that, we are not going to connect the terminal node, another sibling node. So to address that problem, graph is just there is no top actually. It's just node and the relationship. That's it. So to utilize the graph structure for the directory path, we need to have the characteristic of the root. Okay, means it's a tree. So we are going to use the directed graph. It has the edge, has the direction, but it's not. For example, if we just allow the direction, it's a directed graph. It can point each other. It's a cyclic graph. There is a cycle. So we don't know which is really the parent, which one is not, which one is root or not. So it's only one direction, it's acyclic. So we do not allow such a the cycle in the the directory structure. This is called the acyclic graph. The problem is how to share this file from the two different directory. So the file system provide another method. This is called the link. It's very similar as shortcut on the Windows system. Okay, so which means, so if I have a file under the USR, and this is the app one. So this is a.txt file is created under USR, physically located under USR. Then if you create the link from the app to this, you can see a.txt file here, but physically located in the here. This is just a view. So at that time, the Linux or the Unix provide the command ln. Okay, ln is a point the file. So one of that is the real file, the other one is the link. Okay, so at that time there are two types of link. One is the soft link, another one is a hard link. So you can use the -s option, -h option. So and source and destination. So source is the original file. If you want to create the a.txt here, ln -s, the USR parent under the USR a.txt to the current here. So you can create the link of this one. Okay. So this is a soft link. Soft link means if you update this automatically, because it's just a link, okay, physically locate the one file. if you create the hard link actually create the a.txt file here under the app. Okay, hard link. Then, if you update the one of them, they are synchronized. Update the two files. Okay, actually the soft link and hard link are different. Physically, hard link has a physical copy of that, but synchronized. So, using such a link, the command, you can actually create a cyclic graph like this. You can practice. It's a very simple, easily. So, for example, so let's insert the lead here. So you can create the link minus S. So it's a source. You can create the link from the parent under this one is linked to the current directory on the test. So if I create it, so if I list up, you can see the A file. But this one, the arrow means is the link. So you can see the first bit. It's a L. L means it's not the real file, it's a linked file. So what about the cat AA? So you can see the link, even though it's just a link. So if you go to the here, if I update the file like this, it's the original file, source file. So currently I'm in the JELE and going to the test, then the AA cat AA, then you can see it's changed as the Cheongju link. Okay, so this is the way how to create the cyclic graph like this. Then finally, nowadays most of file system support such a general graph directory structure, which means you can see the point to each other, which means we don't know which one is source, which one is not. So this one has the problem of the what if. If this file is deleted, then this one is actually pointed by here, and so we need to keep track of to address, which is called the dangling pointer. So this is the cyclic, the link. So we are not sure which one is real. So for example, if you delete one of them, okay, so actually one of them, what happened? Another link, another file that pointed this one doesn't exist, and that doesn't exist, and so you lose such a thing. So you need to manage when you allow the general graph directory structure, you need to keep track of who is pointing, which files are linking to the current one. So another file can link, another file can link. So you can, when you delete, when you manage such a file, so you need to check which file are linking to that file. So that is the way to implement the general directory structure. So from time to time, you need to do the garbage collection. So if there is any dangling pointer means file linked, but real source file is already deleted. Okay. Then, so finally we have the file system. So file system, we have such the general file system or graph file system, whatever, we have file system. So file system is the software. Okay, it's not the hardware. But eventually our file information will be stored at the hardware, right? So, for example, we have the hardware like this, and this one is the logical, the file system, which is the LBA, logical block, the addressing. So this file system is the data structure. So this should be linked, matched to the hardware. So that is called the mounting. So you are going to mount my file system to the hardware. So finally, when you create the a.txt file, do the mounting somewhere on your hard disk drive or the SSD, the block, logical block addressing, some of the one or the sum of the block will be used to create the a.txt file. Okay, so this is called the mounting. So if you see this one, so you need to keep the two parts. So one is I create the root file and the USR. So USR is the, for example, it's a directory. So once you create the directory, I have the, for example, this is a USB, the flash disk drive. This one has a file system, so it has the file like the Lee and the pattern, and under this one there are the file, and this one is under the root. Okay, so if you mount to the here, then under the USR, the root of your flash drive file system will be mounted on the mounting. This one is called the mounting, the pointer. So mounting pointer, under the mounting pointer, this will be the connected, mounted. So which means under the USR, so you have the Lee or the pattern, and any other the file or directory information will be used. This is called the mounting. So for example here, so if you mount this one to the user, so this is a mounting pointer. So if you mount over here, so that is like this one. So this is the mount. You can find some mounting information on any operating system. The command is the mount. So for example here. So in this case, /db disk1 s1 on the root. So root file system used this device hardware. But as we have seen before, all the device, any the things on the operating system is a file. So this file is used for this device is used for the mounting point of this file system. There's another one, this is a virtual machine. So this virtual machine is mounted here. So then this recovery, the file system is mounted on this one, like this. So you can mount. You can unmount or you can mount anytime using the mounting command. Mount command. Okay. The last one is another important. So file system can manage the number of files. Also, we can use the directory structure. So file structure, directory structure are the two major responsibility of the file. Another thing is the security, the permission. So if you are using your operating system on your personal purpose, like the Windows 3.1 or the Windows 95, it's not a big problem to manage so for example, think about your room, okay, on your dormitory or on your house. So it doesn't matter. So all the stuff in my room are mine. But if you share your room with your friend, so you need to clarify, this is mine, this is yours. Sometimes you can access, you can share this refrigerator, but you cannot share the personal stuff like that. Okay, so we need to clarify such the permission. That is called the file sharing. So operating system use the 2-part, 3-part. So actually, the first permission. What kind of permission we can think about for the file? First, read. Okay, so we can read the data. And another one is write. We can update or modify those are the write permission. And read also include sometimes search, but we will see the differentiate. First search, then what else? Execute. So we are going to execute the executable file after compile or after we create the application. So we have the 3 major operations. However, directory we can read the directory. Yes, we are able to access. we can write, we can create or remove the directory. What about the execution? Execution, there is no executable directory. Instead, for the directory, we are going to bring the search, find the permission for the execute of the directory. So we have the three major. Linux and the Unix like the system use the three permission. And your operating system, the Mac or the Windows, they are using the sometimes slightly different, but actually basically a combination of this one. Okay, so we have the three different IW, sometimes X, the permission. Then the operating system use role-based security control. Role-based means, so you are a student, so you can get all the permission that are permitted on the student. But I'm the staff, so I can get all the permission assigned, grant to the staff, the group, like that. We don't have to assign each and every permission instead as a group. So that is called the role-based access control. So we are going to define the role as a group. So we have the individual user and also group. So for the group, we can create a number of groups. There are special, the group that is public. Public means anyone. Okay, this file can be used anywhere. So there are three different types of group. One is user. User means it's the owner. And the group and public. So user can have read, write, executable permission. Three permission. Group also has read, write, executable permission. Public has group the read, write, executable permission. So 9 permission you can assign for each file. So IWX for owner, IWX for group, IWX for public. 9 permission. So if you list up the file like this, no, not much file here. So you can see IWX, IWX, IWX. If you see the I, that means the first 3, ignore the first the bit. So these 3 bits represent the user, the permission. So which means read, write. So no executable because it's not executable file. And the R for only read permission for the group, only read permission for the public. Who assigned that? Who assigned such a permission? It's a you. Okay? There is a default permission when you create a file. So default permission in this case is 6. The IW for user, R for group, R for public. So how can I change? So there's another command, umask. So using the umask, masking means the opposite. So to explain that, so for example, if you let me explain this one after the permission. So to specify the permission, so we can use the command CHMOD. So change mode is another command. Today we learned a lot of, but these are the very basic and important to use the Linux or Unix system. Change mode. You can directly assign the read write X, the execute read write to the X like that. Instead, the operating system use the number, the to represent this one. So to represent the executor file is 1. To represent the write is 2. To represent the read is 4. So if you want to give the all read write executable permission to the specific group, you can add up all of this. So 7. However, if you want to give the only read and write, not the executable, so 4 plus 2, 6. If you want to give only the read and the executable, so it's 4 plus 1, it's 5. So 0 to 7 number actually indicate all different combination of the the permission. For example, 0 means nothing. 1 means only execute nothing. No. So executable permission. Because 1 represents only executable. 2 means right. 3 means it's 1 plus 2. No other way, right? 1 plus 2 means write and execute permission. 4 means it's a read. 5 means what is a combination of 5? 1 plus 4, right? 1 plus 4 means the read and the executable. And 6 means 2 plus 4. And the 2 is write and the read. The read and write. 7 means 1 plus 2 plus 4. So you can all permission. So you can represent all three permission using 0 to 7. So we can use the 0 to 7, for example, in this case. So 7, 6, 5 to the file name. So you can change mode, change permission using these three combination of the number for the specific file. So for example, right now AA is the permission. What's the number? 644. So I want to change mode. The 777 AA. You can see it's IWX, IWX, IWX. If you want to change it like this, IWX all permission for user, the read and write permission for the group, and the read and executable permission to the public, you can change mode 7, the 6, 5, and 8. Then, if you see, it's IWX, IW, and IX. Okay, so you can anytime change. However, when I create the file, like the touch again, so it's always a 644. So 644 means actually there is a U mask. So it's a masking. So you can actually subtract 77 minus the default permission is 644. That is the 03. It's actually 022, I think. Let me check. So U mask is 022. So I think from 0 is 6. The summation is because it's 0 up to 7. 7 is not the 666. Okay, it's a maximum permission from the masking. We mask 66. So 66 minus 644 is a 022. So your U mask is the 022. So if you want to change it, the default permission, you can change it U mask number. Then the default permission will be changed. We haven't seen a lot of the command, but these are really the popular command to get used to the operating system. So that is the file sharing. What about the Windows? Windows also use the group, so administrator. So administrator, if you see each user permission, it has read, write, read, or so something, the permission. But they are actually combination of this one. Okay. I'm going to skip the remote. That is a protection, so we have seen. You can change the same thing for the group. That is the change group, like this one. Okay. What about the first bit? So we have seen there are total 10 bits for the permission. So we have seen the 9 bit. So what is the first one? First one usually indicate whether directory or not. In case of directory, it's a D, otherwise this. However, the IWX is not the only permission used in the file system. We have another one. S. T. Sometimes S. and sometimes T. So this is a specialized the permission in the file system, which is called the sticky bit. So sticky bit, let me check the sticky bit. This one. If you list up the file like this, so it's a directory, but RWX, R is a T. So T, we never seen the T permission. So T is the sticky bit. So anyone who ever seen the T permission? It's a specialized permission for the usually, what does that mean? Sticky. Sticky note. Sticky. It's a reliable. It's a stick. So the reason why we are using such a sticky bit is for the shareable folder. For the usually shareable folder, like the temporary. We want to use the common room shareable. And this one is actually font. So font can be accessed by everyone. So I'd like to create the font like that. The problem of such a shareable directory, everybody can do something. Read, write. So, but in the common room, if you do not put think about there's a refrigerator in the common room. So you can share. That doesn't mean that you can share the food or container. Usually you put the sticky note. This is a lid. Then I can only access owner of that. Even though room is the directory is the common shareable directory, but I'm the only one who can control this. At that time, you can own the sticky bit, the T. Then only owner of this file, even though directory itself is shareable, but only the owner can control that file. That is a sticky bit. There is another one. So you know the top comment, okay? There is another one, the S. Some of the executable file has RW instead of X, it's the S. Anyone? S is a specialized permission. First, who is the owner of this file? It's a root. It's not me. Okay? Why we need a root permission for the top command? Because it access something critical, sensitive data. It's managed by the root, the administrator. Also, some of them are accessing the specific, the directory folder. Okay? So it is created by the root, but anyone can be owner of that. So if you turn on the stick, this is a set UID bit. Even though I'm not the owner of that this file, but when I run this command, my ownership is changed to the root user. Set UID. Your user ID temporarily changed to this user, original user. So you are able to access the resource. It's only allowed for the root. But even though I run, but my user ID of the process is changed to the owner of the root. So set UID bit is used a lot for such the application that require to access the critical, the resource. Otherwise, you need to give all the permission you don't want. However, because of this one, this is really security hole. Somebody can embed the unauthorized code to this one, then you are acting like the super user. It's usually used for Trojan, the virus program. The Trojan virus program, they try to find such the sticky bit or the set UID bit, the executable file. Okay. Once you are able to put the something code, you are the super user, right? Because it has the set UID bit. So by next week, so there are the specialized permission, set UID, and the sticky bit. Research on what are they, the set UID bit and the sticky bit. Also, I don't explain the capital letter of S, capital letter of T. So including such a the capital letter of set UID bit, capital letter of the sticky bit. So research on and submit to the classroom. Okay, research on, find what is a set UID bit, what is the sticky bit, and I explained the small letter which are popular, but I didn't explain the capital letter T, capital letter S. Why don't you find and bring your research to the class? That will be also used for the your attendance. Also, I'm thinking to use such a question for your final exam. Also, so that is the permission used in the operating system. Then we have done the chapter 11. So why don't you? Yes. Why don't you set up? Yes.
The create and the
Go ahead, Peter.
create and delete files. Like what kind of permissions?
To create the file. The creation means writing. So you should have the right permission for that directory. So, but the only difference is the executable, the execution permission for the directory. So if you have the permission of X for the specific directory, you are able to search under that directory. Okay. So, and the read is whether you are able to read the information about the directory. Yes.
It's set UID and then sticky bit lowercase, but then the uppercase is which one?
Uppercase of both of them.
So
The
like-
large S, large T. There are the special meaning of
Or
that.
it's like capital S for sticky
Yes.
and bit
Capital
capital
S. Yes.
T.
Yeah, they are. You can use such the capital letter S, capital letter T for the permission when you are using the change mode,
So
CH mode.
it's lowercase b, I, and then capital T.
Yes. S, small the T, large S, large T. Okay.
First, using cat command, I can create the file and then put some contents in the file. Yeah, I'm gonna create the zip file. this example just basic file input and output. I already create the file one dash that, and then it gets reading the file using the file input and output. So after scanning, like getting the contents in the file from the file one dot that, and the printf just printing out.
Hello.
This example just writing the file, writing the some contents into the file. You can type any input. Whatever input I just input, then that's gonna store in the file one that file. You can use like a cat command to check which content is stored. So I just type the hello so I can check the content in the file. This is example to create the file using create command. File is created to use a create command. So you can check there is a file created, g.txt file. last example, you can utilize this for your second project. So first the if statement to check like if there is more than one argument, but if there is no argument, the second if statement, then you can check there's no argument you gave. And the last in the while statement, you can check every file in the directory which is running this program. You have to give the argument here. So basically, I can check the current directory here to use a pwd command. And if you put on home here, you can see the next the directory. If you put some directory again, you can see every files in the directory. So using like this while command, you can check every file in the directory. Briefly explain about project 2. to like create the file. I'm going to say portable file system. System. And then there is a file control block. There are several file control blocks. Each file control block contains like the information of the like data block. So file control block contains like the name of the file, the date, file created, the starting point of a data block, and end point of a data block. So each data block you can just declare whatever you feel like. I can say 255 kilobyte. But if your file is like more than 255 kilobyte, you can just like connect using the index. So you can connect each like data block. So there's data block. Each data block has its own like address. So if the file is bigger than one data block, you can keep just connecting each data block. So first, what's important here, you need to declare the file control block. File control flow includes the file name, file size, create time, and create date, and starting block ID and ending block ID. Because if you like put some like bigger data than just one block size, then you can keep connecting the data block. So first, what you need to do is you can just declare file control block. And then you guys have to do like you guys have to implement the put command. No, first you need to open the file global file system. It's nothing but the space. You can create the file control block and then have many data blocks. And then you have to implement the put command. Like you can put any file you are trying to make, and then get command. Put means like you guys are using some operating system. Then you guys can have like some files, and then using put command. First, you need to open the probable file system, and then using put command, you have to be able to like move the file to the probable file system using put command, and then opposite way you have to be able to like move the file, like get the file from your probable file system. similar to this, you can implement it other functions too. Any question?
So this should be the directory in the virtual machine.
Yeah, in the virtual machine, yeah, you can create any like space first, and then create the file control block first, and then after declare file control block, then you can just these are the directory structure because data block has to be connected to each other.
You have to use C language.
Any language you can use.
What do you recommend?
C or C++ because it's easier to access the web address. Okay, if you have any doubts, just.
What about the last thing it said? Managing free blocks. What does that mean?
Free blocks.
It's at the very end.
These are the data blocks. So if you connect data block like this, there are like the spaces left. So you guys can like merge each data block. So you can use the other spaces left, like this empty space, using like a bitmap. When you read about sentence 9, bitmap or linked free space management. You guys learned about this in the class. I think there's a way to merge the space.
So it's like shifting all of those up, or just using the free spaces.
I think you can use it like shifting or whatever, like you find it some way. It's gonna be fine. Just read through the every instruction in the instruction file. Then just try to implement the file control block first, and then